I hope that at this time you understand the issue that makes antidifferentiation a little bit more complicated than differentiation. Whereas each function, if it's differentiable, has just one derivative, a function could have many antiderivatives, and in fact, it can have infinite antiderivatives. Consider the function below f prime of x equals -1. Draw several examples for yourself of functions which could be considered antiderivatives of y equals -1, meaning these are functions whose slope or derivative would be -1. I'll give you a minute to try it and then I'll give my answer. Okay, here's one possibility. We could have the function f of x equals -x. That's a function that is an antiderivative of -1. Here's another possibility. F of x equals -x plus 3. That would work too. And how about f of x equals -x minus 5? Those will work. So this brings us to the notation for antiderivatives. And it is a little bit different from the notation you may have used in the past for derivatives. But they do have some things in common. For example, when we did differential notation in the past, we would have used d, little d, which stands for an infinitely small differential. And that is used in the antiderivative notation as well, but it goes in a different place. What we want to do is we want to take the function f of x that we're trying to take the antiderivative of and surround it with two things. We want dx on the right and this integral sign, which is the sign for taking an antiderivative, on the left. And they act like parentheses around the function that we're doing the operation on. So let's try to use that notation real quick for this function of -1. And see what it looks like. That says take the antiderivative of the function -1. Now, when we find an antiderivative of f, little f, we want to distinguish it from what's called big F. Big F is the antiderivative of little f in this context. And so big F is a function whose derivative is little f.